Hi, welcome to my second video on proof by induction for divisibility. We've just got another example, same sort of difficulty as before, but just to show you again with a separate case. It's a very tricky topic, this, and one of the hardest types of proof by induction. So it's good to see lots of examples. Before you try it, repeat the steps you did for the previous question, and see if you can get as far as you can, or maybe even complete the question. After that, have a look at the video just to check your own working. Alright, let's begin. So first of all, we do our base case. Base case, always very easy. So base case. Now actually we're talking about n being greater than or equal to 0. So our dominoes are falling from 0. So 0, 1, 2, 3, 4. Instead of from 1, which is what we've seen in every other example so far. So base case, n equals 0. So we have 8 to the power of 0 minus 2 to the power of 0, which is 1 minus 1, which is worth 0. Is 0 divisible by 6? Well, it is. For it to be divisible, we need to be able to write the number as the number that we care that's divisible by, so 6, multiplied by an integer. And in this case, we can write it as 6 times 0. So in fact, every single number divides 0. So we get that it's true for our base case. Next, this is where we get our assumption. So assume true for n equals k, i.e. 8 to the k minus 2 to the k is equal to 6a, where a is some integer. So this is the definition of being divisible by 6. Next, like before, I'm going to leave a little bit of a gap between this line and my consideration line, because we're going to want to rearrange our assumption. So consider n equals k plus 1. So 8 to the k plus 1 minus 2 to the k plus 1. And we're going to do a bit of rearrangement with it. Now, before, what we saw is that we would get one term on one side, and that would allow us to introduce a into here. So we're just going to do it again. This time, we're going to put 8 to the k on its own. So we get 8 to the k equals 6a plus 2 to the k. I can't quite replace this in my expression, so I'm going to multiply both sides by 8. That's going to get me the 8 to the k plus 1, this term here. So we get 8 to the k plus 1 equals 8 times 6a plus 2 to the k. That's it. So our whole goal with this was then to replace it in our expression. So we're left with 8 times 6a plus 2 to the k minus 2 to the k plus 1. Now we're trying to show that there's a multiple of 6 in here. We can take out a factor of 6. So like we did before on our left, we're going to put all terms that have a factor of 6. So clearly when I multiply out by 8, this term's going to have a factor of 6. This is going to be 6 times 8a plus 8 times 2 to the k minus 2 to the k plus 1. So this is already done. This is not done. So on our next line, well, I'm looking for a factor. I'm looking to factorize this expression. This is a factor of 2 to the k, and actually this here is 2 times 2 to the k. So I can factorize this, and this is a very common trick. Whenever you have like a +1 in a power or a -1, you can search for common factors. So this is going to be 2 to the k times 8, and well, if I factor out a 2 to the k of this one, we're going to have a -2. This leaves us with 6 times 8a plus 2 to the k times 6, which is the same as 6 times 8a plus 2 to the k. So what we've shown is that the k plus 1th term must also have a factor of 6. So as true for n equals k plus 1, when true for n equals k, it must be true for all n bigger than 0, our base case. And finally by mathematical induction. So I've slightly changed the wording, it doesn't matter, I've just shown you that you can be quite flexible with this. But anyways, thanks for watching, and I'll see you in the next video.